Okay, now for the second kinematic equation, what I'm going to do is, so once again, remember we're assuming the acceleration is constant. Now, then, well, if you remember average velocities, right, we decided its displacement over time. Now, if the acceleration is constant, then I can think about the average in a little bit different way. So for example, imagine I threw two numbers at you, so 5 and 7, and I told you to average them. What would you do? Well, you would add them together and divide by 2, right? So 5 plus 7 is 12 divided by 2, so the average of 5 and 7 is 6. Now, we can do the exact same thing for average velocities as long as acceleration is constant. And I can say average velocity is going to be 1/2 final velocity plus initial velocity. Okay, so where do we go from here? Well, from this guy up here, let me just rewrite this a little bit. I'm going to write this as x minus x initial, which we said was going to be 0, divided by the t minus t initial, which is also 0. So I can set these two guys equal to each other. So this is going to be x over t, which is one way to write the average velocity, equals 1/2 v plus v initial, which was a different way to write the average velocity. And they're both average velocities, so they should be equal to each other. And then let me just rearrange a little bit. So I'm going to write this as x, so we multiply both sides by a t. So this is going to be 1/2 v plus v initial over t. And that is kinematic equation number 2.